Hello again, everyone. Mr. Cruze here with part 2 of the Chapter 4 test review for Prob and Stat. Hopefully you found the first video helpful, so let's just get moving. Number 10. In a box of 11 parts, 4 of the parts are defective. 2 parts are selected at random without replacement. Aha. That means those are dependent. Find the probability that both parts are defective. This means, aka, probability that the first one is defective and the probability that the second one is defective. So this is an and question, which means you're going to multiply. So what's probability the first part's going to be defective? Well, there are 4 defective parts out of 11 total. It's an and problem. But again, notice it's dependent, which means the second probability changes based on the first. So the second one will be 3 out of 10. 3 out of 10 because you've already picked the first one as defective. So it brings you down to 3, and now it's out of 10 because you already took a piece out. Anyway, multiply that together, I believe you get 12 out of 110, which reduces to 6 over 55. And again, if you'd rather do percents than fractions, go for that. You don't have to worry about reducing percents. Find the probability that both parts are not defective. Okay, this is a little tricky. The temptation here is to want to go 1 minus 6 out of 55, right? Since that's probability that both are. So if I want probability that both are not, I would just subtract. Turns out they're not quite complementary events, because it's possible that I could get one that's defective and one that isn't. So I have to be a little more clever here. That both parts are not defective. Well, what's the probability that the first part's not going to be defective? Since there were 4 defective, that means there's going to be 7 that aren't, right? 11 minus 4. Times, once again, and again, we're still not replacing, so it'll be out of 10. How many will not be defective the second time? 6 out of 10. So go ahead and multiply those two together. You get 42 out of 110, which reduces to 21 out of 55. Pretty neat. Alright, number 11. A company that makes cartons finds the probability of producing a carton with a puncture is 0.05 or 5%. The probability the carton has a smashed corner is 0.08 or 8%. And the probability the carton has a puncture and has a smashed corner is 0.004 or 0.4%. If a quality inspector randomly selects a carton, find the probability that the carton has a puncture or, notice this is an or question, or has a smashed corner. Remember, anytime you see or, that means you're going to add some probabilities together. But you must remember, are the two events disjoint? Is it possible that they don't happen together at all? Or are they overlapping, which means they can happen together? If they are overlapping, you must remember to subtract out the overlap, okay? And it turns out, if you read the question, this part right here talks about how they do overlap. The probability that it has both. This is an overlapping question, which means I need to subtract out the overlap. So add the two initial probabilities. Probability of getting a puncture is 0.05. Probability of getting a smashed corner is 0.08. If they were not overlapping, that would be it. You would just add. But we must also subtract the overlap because they do overlap. We don't want to count it twice. Anyway, simply typing this in your calculator gets you 0.126, or if you'd rather, 12.6%. Number 12. 5 discs in a bag are numbered 1, 2, 3, 4, 5. What's probability the sum of the numbers on 3 discs chosen at random is greater than 10? Greater than 10 means 10 does not count. 10 doesn't count. It's strictly greater than 10. So, think of this as a probability question, right? Top and a bottom. The bottom will be the number of ways I can just draw 3 discs out of the 5, right? Does order matter? Does it matter if I draw 1, 2, 3 or 3, 2, 1? No. So this is combination. So there's 5 total discs out of, and I'm picking 3 out of those 5. The top, though, I need to figure out how many ways can I get over 10, right? So what ways will that happen? 5, 4, and 3. That'll add up to be 12. That's bigger than 10. Always start with the bigger numbers first, right? 5, 4, and 2. That would add up to 11. That's good. 5, 4, and 1. Well, that adds to 10, which doesn't count, like we said. And really, those are the biggest possibilities you can get. The next thing will be like 4, 3, 2, which isn't big enough, right? So it turns out there's only 2 possible ways you can get greater than 10. It turns out 5 combination 3 is 10, and 2 out of 10 is 1/5 or 20%. Alright, 3 marbles are drawn at random from a box containing 5 red, 8 black, and 4 white marbles. Determine the probability that all 3 are white. AKA, what's the probability that I get a white, and a white, and a white? This is an and question. Notice we're drawing them at random, just picking them all out at once, basically. So we're not replacing. So this is totally dependent. Right? Whatever I draw the first time will affect the second and the third draws as well, right? So, what's the probability I get a white on the first draw? Well, it turns out there are 4 white out of, I believe, let's see, 17 marbles total. 5, 8, and 4, yep. So, times, what's the probability I get a white on the second one? Well, I already picked 1, so I'm down to 3, and I'm down to 16 marbles total. Same thing on the third one, I'm down to 2 white marbles, because I picked 2 on the first times around. Out of 15. A little bit of clever reduction if you would like. You could reduce the 3 into the 15. The 4 and the 2 will multiply to 8, which goes into 16 twice, and I think that's all you can really do. So you end up getting 1 out of 17 times 10, which is 170. Okay, and your calculator might be able to reduce that fraction for you. Alright, how about 2 are black and 1 red? So what's the probability I get 2 blacks, so a black, and a red. Well, again, how many blacks are there? There are 8 out of 17 for the first go-around. There will be 7 out of 16 for the second go-around. And then on the third pick, it'll obviously be out of 15 total, because I've already picked 2 marbles. But how many reds are there? Well, picking black didn't affect the number of reds, so I still have 5 reds total. Again, a little clever reduction here. 8 goes into itself once, goes into 16 twice. 5 goes in once, 15 3 times, and I think that's all that reduces. So you end up with 7 out of 17 times 6, which should be 102. And 1 of each color is selected. Now, this is interesting. Basically what this is probability of getting a red, and a black, and a white. And you'll notice, actually, you might think order matters here. What's probably I get a black, and then a white, and then a red. But it turns out it doesn't, because when you multiply the fractions together, multiplication is commutative. It doesn't matter what order it's multiplied in. So, everything will work out fine. So what's probably I get a red? Well, that'd be 5 out of 17. On the second draw, it'll be out of 16. The black will be 8. And the white will be 4 out of 15. And again, it doesn't matter. If I started with white, it would have been 4 out of 17. And then black would have been 8 out of 16. And then red would have been 5 out of 15. It still would have multiplied out to be the same. So let's see what we got. 5 and 15. Let's see. The 8 goes in once, twice there. Oh, the 2. So I'm down to 2. So it ends up being 2 out of whatever 17 times 3 is. So that's 51. 2 out of 51. Alright, 43 racers started the 2001 Daytona 500. How many ways can the cars finish first, second, and third? These are places. It'd be different if I got first and you got second and somebody else got third, compared to you getting second, you getting first, me getting second, and somebody else getting third. So this is permutations. Order matters here. It matters if I get first, second, or third. So there are 43 total people. I'm picking the top 3 spots. And you just type that in your calculator. It's a simple permutation question, nothing tricky there. Alright, number 15. In how many ways can the 13 players form a circular huddle? Ooh, circular permutations around the coach during a timeout. You might remember anything circular permutation. A revolving party tray, circular huddle, something like that. How many ways can we line up in a circle? N minus 1 factorial. So there are 13 people minus 1. So that'll be 12 factorial, and you type that in your calculator, and you get a big honkin' number. I believe it's 4,790,000,1,600. It's a big number. Alright, let me go to the POD questions I gave you the other day just to make sure we got these. I'll try and get through these as quick as I can in the next couple minutes. What's the probability that a coin will turn up heads at least once in 6 tosses of a coin? This is that binomial probability, which is NC n minus r times p to the r times q to the n minus r power. So I need n, p, q, and r. So N is the total number of times I'm doing it, which is 6 tosses. P is the probability of success. Well, the probability I get a heads is 1/2. Q is the probability of failure, which the probability of success is 1/2. The failure must also be 1/2 because they have to add up to 1. And R in this case, at least once. Well, I want 1 success or more. So any of these will work. But do I really want to do it 6 times? Nah. So I'm going to take the other option. Always take the shorter option. I'm going to do 1 minus the other event. What if R is 0? Make sure, though, that you do 1 minus. Otherwise, you'll mess this up. So let's just do R equals 0 and then subtract it from 1. So here we go. If R is 0, it will be 6 combination 6 minus 0, which would be 6. P, which is 1/2, to the R power, which is the number of successes I want, which would be 0 in this case, times 1/2 to the Q, or sorry, 1/2 to the N minus R, which would be 6, because I want 6 failures. Simply typing that in your calculator. Again, I'm not showing you how to do that here. If you have questions, I can help you in the morning. 0.0156. And then you subtract, and you get 0.9844 or 98.44%. Either one. Okay. What's the probability of throwing a sum of 8 or, make sure it's an add problem, 11 in a single throw with 2 dice? Well, anytime you throw 2 dice, there are 36 outcomes total. Please make sure you remember that. A lot of people were putting it out of 12 on the last quiz. Be careful. So I need to know how many ways can I throw a sum of 8. Well, let's think of the ways. There's 2 and 6, which means there's also 6 and 2. There's 3 and 5, also 5 and 3. And then last but not least, 4 and 4. And notice the last one I can't flip because getting a 4 on the first die and a 4 on the second die is the same as if I switch those two, right? Whereas getting a 3 on the first die and a 5 on the second is different from getting a 5 on the first and a 3 on the second. Okay. So there are 5 total ways. So it'd be 5 out of 36. Plus, how many ways can I get 11? Well, I can get 5 and 6, or 6 and 5. There's only 2 possible ways to do that. Now, ask yourself this question. Are these overlapping, or are they disjointed? We'll take a look at my choices here. Are any of them the same? The answer should be no, which means these are disjoint. I can't possibly roll an 8 and an 11 in the same throw, right? That would make Monopoly very interesting. So there is no overlap to subtract. So it's simply 7 out of 36. You just add. Alright, 2 more to go. Come on, Cruze, we can finish this. Multiple choice quiz has 3 questions, each with 5 answer choices, A through E. Only one of the choices is correct. You have no idea what you're doing, so you just guess. What's the probability of answering the first question correctly? What's the probability you guess the first question correctly? Well, don't overthink this. You guys know what the probability is of guessing. It'd be 1 out of 5. Okay. Well, what's the probability I guess the first 2 correct? Well, I still have a 1 in 5 shot on both. But this is kind of an and, right? Probability that I guess the first one right, and the probability I guess the second one right. So I'm going to multiply. Obviously, they're independent. They don't affect each other. So it's 1 out of 25. How about I guess all 3? Well, that would be 1/5 on each one, right? 1/5 times 1/5 times 1/5, which is 1 out of 125. And finally, what's probably, I guess, none of them correct? Well, think about this. If I have a 1 in 5 chance of guessing it correct, then don't I have a 4 out of 5 chance of guessing it wrong on each question? And you just simply multiply those together, and you get 64 out of 125. Alright, let's see if I can get this last one done in a minute. 4 cards are drawn from a deck of 52. Find the probability that all 4 are kings. Well, there's 4 kings total out of 52. I'm just picking 4 cards, not replacing, so I only have 3 out of 51 on the second shot, 2 out of 50 on the third shot, 1 out of 49 on the second shot. Multiply that together, you should get a probability, if you reduce it correctly, of 1 out of 270,725. What's probably that 2 are kings and 2 are aces? Well, again, starts off the same. 2 kings. But now there's 4 aces left out of 50, and then 3 aces out of 49. Multiply this one together and reduce it, you should get 6 out of 270,725. And last but not least, all are of the same suit. Well, there's 13 cards that are the same suit. 12 out of 51 on the second draw, 11 out of 50 on the third draw, and 10 out of 49, which gives you a probability, when reduced, of 11 out of 4165. Alright, if you have questions, feel free to ask me. See ya.